All right, hi there everybody. In this video we're going to talk about dividing complex numbers. We'll get into how that all works in a little bit, but first I'd like you to do the activator problem that you see here. Multiply the quantity a plus bi times the quantity a minus bi. Go ahead and pause your video right now for a few seconds and come back and we'll talk about this question. All right, so looking at this activator problem, we want to multiply these out. We've got two binomials. We're going to go ahead and FOIL these out. So we've got a times a gives us a squared, and a times a minus bi gives us a minus abi, and plus bi times a gives us a plus abi, and then plus bi times minus bi gives us minus b squared I squared. Now, these central terms, the minus abi and the plus abi, cancel each other out. And you remember from before that I squared, since I is the square root of -1, I squared is equal to -1. And so this becomes a squared minus b squared times -1, which just simplifies to a squared plus b squared. And that's what we get when we multiply these two numbers together. These two numbers you see in the first section here, these are what are called complex conjugates. A plus bi and a minus bi are what are known as complex conjugates. The product of these is a real number, just like you see here, a squared plus b squared. By multiplying these two together, we could make the i's disappear, the imaginary part of our complex number disappear, and we end up with a real number value. The idea of complex conjugates are crucial to how we're going to divide complex numbers. So let's go ahead and we'll continue on. Dividing complex numbers. So it says here, math etiquette tells us that all imaginary numbers must be removed from the denominator of a fraction. So we never want to have an I in the denominator of any expression. So let's simplify 6 over 5i. Now how can we get rid of that? Well, the fact that I is equal to the square root of -1, we do this a lot like we used to, a lot like we've done in the past when we were rationalizing denominators. You know, if we had a single radical in the denominator, we would just multiply both numerator and denominator by that radical to get rid of the radical. We're going to do the same kind of thing with i's. Since we've got 6 over 5i, I'm just going to go ahead, I'm going to multiply the denominator here by I, and then in order to maintain the value of this expression, I'm going to also multiply the numerator by I. And that gives me 6i in my numerator over 5i squared. And remember, I squared is equal to -1. So this is 6i is equal to 5 times -1, or 6i over -5. I normally like to bring the negative sign out in front of my fraction, and so I would write this as -6i over 5. And that's how we can get rid of a single I that shows up in the denominator. Let's do another example. In this example, now we have a binomial. And just like when we were, rationalizing denominators before, if we have two terms in our denominator, one of which is an I, the way we're going to deal with this is by multiplying by the conjugate. In this case, we're multiplying by the complex conjugate that we just learned about above. So we want to multiply this denominator, 3 minus I, we're going to multiply by 3 plus I. And we're also going to multiply the numerator by 3 plus I. All right, and so now we want to go through the simplification process here. In the numerator, I've got 4 plus 2i times 3 plus I. And in the denominator, I've got 3 minus I times 3 plus I. I'm going to go ahead and expand those. So we'll FOIL it out. 4 times 3 is 12. And 4 times I is 4i, and 2i times 3 is 6i, and 2i times I is 2i squared. In the denominator, I FOIL it out. 3 times 3 is 9. 3 times I is 3i. Minus I times 3 is minus 3i, and minus I times I is minus I squared. Now, just like when we were simplifying radicals, this these two terms in the middle, when we multiply the conjugates, they're always going to drop out. So eventually you get to the point where you don't even really write those in. So now I want to simplify this. A couple more things I can do here. I've got some like terms in the numerator that I can combine. I also have some I squareds that I can replace with negative ones as I simplify this in this process. So let's see, I'm going to have 12. I'm going to combine the like terms plus 10i, and then plus 2 times negative 1 makes this a minus 2 all over 9. The plus 3i and minus 3i cancel each other out. Minus I squared minus negative 1 is plus 1. And then we just need to combine the last few terms here. We're going to get 10 plus 10i all over 10. Wow, that couldn't have worked out nicer. I can take a 10 out of both things in the numerator and then cancel that with the 10 in the denominator, and we end up with our final answer of 1 plus I. All right, moving on. Couple of problems for you to try. Go ahead and pause your video for a bit and go ahead and do these problems, and then when you come back, you'll be able to check your answers with the answers that I have. So go ahead and pause your video now and work out these problems. All right, welcome back. You see the solutions now to these problems. Quick little run through in example A. Since we only have a single term in the denominator, we're just going to multiply numerator and denominator by I. We distribute the I through the numerator and multiply the I times the single term in the denominator. We replace our I squareds with negative ones. And then I'm going to write my answers for these in the form a plus bi, so I actually split the fraction into the real part and the imaginary part here. I take the positive 6 over negative 2 to get minus 3, and I take the 9i over the negative 2 to get minus 9 halves I. All right, and then part B, we multiply by the conjugate, and then we're going to FOIL things out. After we're done foiling things out, we're going to combine like terms in green and yellow, and we're going to replace the I squareds in pink with negative ones, which gets us 2 right here. And then we're going to combine our like terms. We split it into the real and the imaginary parts, and then we're going to go ahead and simplify those and reduce those. All right. Continuing on, I'm going to ask you to pause again. In your packet, you have 1, 2, 3, 4, 5, 6 problems here in the practice section related to simplifying expressions with i's. So what you're going to do is you're going to go ahead and pause your video, and when you're ready to talk about these 6 problems, you're going to go ahead and come on back and unpause. All right, so go ahead and pause now. All right. All right, we're back with our answers to the practice problems. You see here what I would do in the first problem is I'd go ahead and combine these first 2 numbers together by just adding, and since we're subtracting this, I would go ahead and change my signs and get rid of the parentheses, and then we just combine like terms to our final answer. Part B, we distribute the 2i through, we change the I squared to a negative 1, and then again, I'm writing all of my answers in a plus bi form as I go here. In part C, we have a single term in the denominator containing an I, so we multiply by I over I. We distribute the I through the expression in the numerator and multiply it times the expression in the denominator. I replace my I squareds with negative ones, and then I divide both terms through by the negative 5 here and write it in a plus bi form. In part D, we're going to use the complex conjugate. Multiply numerator and denominator by that, and so we FOIL out the numerator and the denominator. We combine the like terms highlighted in yellow and green in the numerator and denominator and replace the I squareds with negative ones and simplify, and then we combine our like terms there and split it into and put it in a plus bi form. Part E, first thing I would do is just go ahead and distribute the negative 2 through the first set of parentheses. You know, we've got 3 things multiplied here. We've got to multiply them 2 at a time. I could FOIL everything out and then multiply by negative 2 in the end. I think it's just easier to just go ahead and distribute that through and then FOIL everything out. But we go ahead and do that and combine our like terms and write our answer as a plus bi. And then here in f, we're going to multiply by the complex conjugate. So we go ahead and do that. And that gives, and then we distribute, replace our I squareds with negative ones, and simplify and write it in a plus bi form. All right. I think that's where we're going to call it quits for this video. I'm going to go ahead and come back and do a second video for the rest of this lesson. So make sure you come back to check that one out. All right. See you then. Bye-bye.